Okay, welcome back to Calculus 1000. We are moving toward what is called yeah, tell me when you're done so that I can start. I can wait. Thank you. So we are moving towards what's called definite integral and techniques and tools related to that. Today we will start with finding area, and then, well, on Wednesday you will see that what we have done is basically definite integral with a little bit of more games played there. We can get the general theory out. So, but today the goal is area under the graph. So area under the graph of a function. So where the story starts simple and easy to understand. I have a function. I assume it is continuous and positive. This week we are only today I'm assuming that f is positive and continuous on the given interval AB. When you have positive and continuous, then you have a very nicely defined region under the graph. Here, what I mean under the graph is region above x-axis under the graph of the function from the point A to B. We want to evaluate this thing. Or find a way to find the area of such thing. For example, if the function is constant function, yes? In the case of constant function, you know the graph of function, well, here assuming that C is positive, is a constant horizontal line, and the region defined by the graph on the interval AB is nothing but the rectangle there. Well, yes, square is kind of rectangle, yes. And in that case, the area is easy to find. What we do is like the width there times the height here. Yeah? So width here in this simple case, and only in this case, is b minus a, the area. The width is always b minus a. Times the height. Height is given by the value of the function, which is always constant, so times c. Okay? We can do, without calculus, area under the graph of a function, a linear function, something like that. Yeah? This is not very difficult to do because that is, what kind of shape is that? Does anyone remember the name for that? Yeah? Right trapezoid. Right trapezoid. So in that case, what we do is that we take this part, which is b minus a, and then we multiply, well, the area of the trapezoid says this plus that times that divided by 2. So here, this value over there, what is this value over there? Yeah? This was b minus a. How about this one? What is it? Yes, please. F at B, this is the function, the height of the function, or the height of this point, or y value of that point on the graph of function, which would be F at B. And then this part, then obviously is F at A. We add these two things. We multiply by the B minus A and divide by 2. That's the area of the right trapezoid. Or in general, trapezoid, you find the area like that. Well, when it comes to a function like simple function, like x squared, then you will notice that, oh, now the story is way more than just trapezoid, rectangle, triangle. This is now a story of a very general, like if you want to evaluate this area of this thing, you will find that, oh, this can be applied for any function that you want. But the main and key idea here is that to find the area, we will give out first the precision. We will try to estimate. Then the precision will be achieved by finding a limit. So now, unlike these two cases, where I can give you a formula right away, done, I have everything. In the new case, or in general case, we are going to split this story into two pieces. I want to first estimate. If my estimate turns out to be a nice estimate, then I can make my estimate better and better. In our case, that making better and better will be achieved by finding a limit. Let me now walk you through these two steps. For the moment, we are trying to estimate the area using rectangles. Again, my function is very general function, positive, continuous. Now, the way I want to do this is this, that I want to cover this region using rectangles. However, since there is no straight line on the graph, well, my rectangle sometimes will cover more than the region, and sometimes will cover less than the region. Okay, here is what I will do. I will divide this interval into n equal subintervals. I'll call this one x1, x2, x3, x4, all the way. Yeah? And using each subinterval, I will make a rectangle. What is this rectangle? I'll just find the rectangle whose height is all the way from the x-axis to the graph of my function at the right end point of my subinterval. Let me do another one. The second rectangle will go all the way to the graph. That's the second rectangle. Third rectangle. Let me do the last rectangle as well. This, I am not claiming this is going to, by just that calculation, I'm not going to get the area. This is estimation of my area. Why? Because sometimes the area of the rectangle I'm using will be bigger than the area of the region, or it will cover parts of the rectangle will have parts that are not under the graph. And sometimes I will get parts that are not covered. I want to formulate this piece. For the moment, forget where is the precision will come. What I want you to worry about is that I want to find the area of the regions covered by these rectangles. Okay? Does that make sense? Are we all on the same page? I didn't hear anything. Are we all on the same page? Yes. Okay. I can live with that. Okay. So each rectangle, I need to get two values for. One, the width, the other one, the height. Let's work on the width first. Remember that I said I am dividing my interval into n equal subinterval. So that's my first step. Divide interval AB into n equal subintervals. Well, sorry, I will cover this part so that I can use the two boards there. Well, what does that mean? This, just by saying that, dividing an interval into n, I know that the length of each subinterval all the subintervals are equal lengths. The total sum is b minus a. I divide it by n. That's the length of each one of these subintervals. I will use a notation here. I'll use delta x for this. Well, based on how I'm going to create rectangles, I see that, oh, this is nothing but the width of my rectangles, because the rectangles I'm creating on those subintervals. Yeah? The second thing I need to know is the height. To evaluate the height, I need to go on the ith interval. Let me write this. So ith interval. If I call A my x0, then the first interval is x0 to x, x0 to x, 1. Second interval is from x1 to, I want to hear that, from x1 to, third one, and ith one will end to xi, and it will start from 1 less. From x2 to x3 is my third interval. From x5 to x6 is my sixth interval. Yes? But I want to get the end point of the ith subinterval and use it to find my area. Let me just write it here again, this one. So this is xi minus 1. This is xi, yes? This is the width of my ith rectangle. The height is given by this. The height, as we did for that example, is, oh, is f at xi. So the width is delta x, the height is f at xi. Well, then I can find the area. But before I go ahead and find the area of the ith rectangle and then add them, I want to make sure that we are moving from this point, knowing that what is the value of each xi, because I have to evaluate function at xi. I'm looking for the value of xi given in terms of a and delta x. Let's see. For example, x0, I will erase this part, but I can write. x0, I know that it's a. That's how I decided to index my endpoints. x1, what is value of x1? What is value of x2? And what is value of xi in general in terms of a, b, and index I? Is the question clear? Can I get a confirmation? I want to give you 30 seconds to talk to your friend and get that done, yes? Is the question clear? I'm looking for a formula for xi in terms of a, b, I, if there is any a, b, or maybe delta x you will use, yes? 30 seconds, you're talking to your friend, chatting about this. Let's see if I can write x1 in terms of a, delta x1 or something. How about x2? Can I generalize it? Can I write it in terms of a, delta xi, and general, okay? Go ahead, please. You have 30 seconds. I don't want you to write anything down. You're talking to your friend. You're trying to come up with a formula for that. Go ahead. Ten more seconds. Okay, do I have any volunteers to tell us? What did you figure out? One volunteer. One person. Yes, please. Thank you.
I thought that the general equation for x to the I was
Can we go with x1? What was x1?
a plus x to the 0.
Sorry, what was it? I cannot hear him, please. Yes.
X at 0 or 0.
A plus x0? Is that what your formula is? Sorry? Let's see, how are you getting that? So if this is my x0, which is a, then x1 is this much added to x0, yes? How much is this? This is the length of subinterval, yes? And we denote it by delta x, yes? So my x1 will be, you start from a and you add to that delta x, yes? How about x2? Yes?
Plus 2 multiplied into delta x.
Now, for a2, you need, again, start from a, but you need 2 subinterval, 2 delta x. So this will be a plus 2 delta x. For a3, you will need, starting again from a, how many delta x's? 3. For xi, I will need a plus I delta x. So I start from a, I go 1 delta x, 2 delta x, 3 delta x, 4, 5. This is x5. Yes, how do you like it? Yeah, simple. So I will write this formula also here. Now I can erase that and go. So now, so far, I have found all the components that I will be able to use it to find the area of each rectangle. Now I want to find all these sums of these rectangles, put them together. So this is step 2. Find the estimation using triangles, your rectangles, sorry. So my estimation, I need to choose something for that. I will use R. Why I'm using R? You will know on Wednesday. Number of divisions, F, sorry, N, how many sub intervals we created. Function, whatever the function is, because I'm going to use it, yes? F there. Sometimes in the notation, you will see me adding the interval as well. Sometimes I will drop it, but that is basically now what I'm trying to find here. These I want to find what is the area of the region covered by rectangles. Now, obviously, I need to add area of first rectangle plus area of the second one, area of ith rectangle, and then I'll go all the way area of nth rectangle. Yeah? That will be my estimation, okay? Let's do, what is the area of the first rectangle? What is the area of the first rectangle? I need to hear that. Area of the first rectangle. What is happening? Yes, please.
Would it be A times F of A?
F, everything is here, yes? The first one, this is the 1, yes? The width is delta x, so I can multiply delta x times, what is the height? F at x1. The area of the second rectangle then is f of x2. You're not with me today. F of x2 is the height of the second rectangle times delta x. Yes? And for the ith rectangle, I have f of xi times delta x. Yeah? And then I can go ahead and do the last one. That's good enough, isn't it? I have everything there. But I want to write it a bit more concise. If I have terms like this plus that, plus that, plus that, how did I show it in more concise way, such addition? Yes, sigma notation. Sigma notation is now instead of writing all, I can write sigma I subinterval, I goes from 1 to n, f of xi times delta x. Okay? Or I can put the value of xi there, and I can say that this is f of a plus I delta x times delta x. I goes from 1 to n. Yes, please.
I start, would it be I equals 1 or would it be I equals A?
C. X at 0 is A. X at 1, x2, x3. What is counting here is this index. A is not one of the indices. A is just a number that x0 happens to be equal to A. So in other words, what you should see this, what I'm writing here is this. I'll erase this. I equal to 1 to n, area of ith rectangle. That's what I am aiming to do. But I have a formula for the area of the ith rectangle, and that's equal to that. Well, we will do an example, and you will see how this turns out. But the key point here to see that Rn FAB will be or can be evaluated and written in terms of N, A, B, and F. I'll put these ones in the bracket. If the formula of f of x is given, and a and b are two numbers, you won't see a, b, f in the final formula. In the final formula, the only thing you will see, it is going to be a function of n. Meaning what? If I divide this to n 10 pieces, I'll get one estimation which depends on 10. If I divide it in 100 subintervals, then I will get something which is in terms of 100. If I divide it to 1,000 intervals, then I will get something in terms of that 1,000. So by changing the number of subintervals, my number will change. Okay? This is the end of estimation. Now I want to take this estimation and use it to find the actual area. Would you like to talk to your friend to see how you can do that by knowing Rn? Yeah? 30 seconds. At least I'm hoping that will make you to talk to someone. You're not talking to me. Before that, I have a question here.
Why is there brackets?
I said that at the end, since a and b are going to be number and function f, we are going to have expression for that. You won't see a, b, f into your formula. The only thing you will see for the formula is that n. So at the end, you're going to find something in terms of n. Yeah? Okay, I give you 30 seconds. Now that I have this estimation, how using calculus, I can move ahead and turn that estimation to an exact value of the area. Go ahead, 30 seconds. This is a good brainstorming. And talk to someone. Don't sit quiet there, please. Find someone next to you, talk to you. Talk to them. Talk to them. Talk to them. Okay. Does anyone want to share with us what you think we should do for that last step? Let me see if someone from back there. Yes, yes, please. Loud. Limit of Rn as n goes to infinity. Can you tell us why you think that would give us?
You want an infinite number of n, like infinite number of rectangles.
But how infinite number is related to the area here?
So like area.
The smaller the widths of your triangles are, the less over area or under area you will have. Well, it's not quite clear just by this argument that those small pieces will go to 0. But mathematicians have proved that a function is continuous and you make the widths of your subintervals as small as you can, then those over or under estimation will go to 0. Making the widths smaller and smaller is the same thing as increasing the number of subintervals. Another way of seeing this is that no matter how good the graph that you draw on a computer screen is, if you zoom in at the end, what you will see is that what you were seeing was like small pieces, pixels, yes? Like that. But since there are so many of them, you see it as a smooth line, curvy line like that. Yes? That's just one aspect of that idea. Okay? So if you do that, then you will get the area. And in this last step, it's not anymore depending on A. Sorry, it's not anymore depending on n. It's just a number. Okay? How confusing are these steps? Be honest. How confusing it is. Just step 3. Oh, I love it. What else? Let me hear. I want to hear how confusing are all these 3 steps. Yes?
In the final formula you wrote for area, is that Fi, AB?
You mean this guy or this?
No. The one you pointed to.
Here? This is comma. Yeah, I'm using comma here just to say that this is depending on f and the interval. Yes, no. Any other confusion point? I'll get back to the third point. So let me show you an example what I mean this part. I see that it is a bit confusing here, but we will get to that in that example of parabola and you will see what we are doing.
Comma and then.
So I put these ones in brackets, meaning that, yes, at the end it depends on A, B, and F. But if we plug in the value of A, B, and the expression for F, they won't show up in the final formula. It will be something in terms of n. I will show you in the example. That's why I'm saying that. Wait for an example. Yes, please.
That area over there is equivalent to the sigma notation area of I thread.
This n goes to infinity? No. So that I can explain a little bit more, but not really. Yeah, there is an n also involved in delta x and f of xi, and that's the issue. If there was no n inside, that would be going from 1 to infinity. But no, that's not happening. You're welcome. One more question I'll take, and then we'll do example. Yes, please, loud.
Corner, say n comma bracket ABF.
A, B, and F. So just wait 5 minutes.
Before the bracket.
So my original writing was this. N comma, A, comma, B, comma, F. So there are 4 things, A, B, F, and N. But after I evaluate those things, what is the value of A, what is the value of B, what is function F, you won't see A, B, F anymore in it. The only thing you will see is N. Again, wait 5 minutes, I'll do an example and I'll point out when we get there. Do I have any question from that part? Yes?
Not related, but that is n approaches infinity, right? Not
Yes.
it looks like an H.
No, it's N. I don't have any H's here. So it's N. Yes, thank you. Let's do this example. Let's do this example now for the function x squared and find what is all these 3 steps. But what I will do is this. I want you to take all these steps for this example at least, very literally what I have written down. So you say that n, what is delta x, what is this guy, and what is that guy. That's step 1 of you. Step 2 is what you write this one down and simplify as much as you can. Step 3, we will do this one. For each step, I'll give you 1 minute so that you can start the work, and then I will complete that, okay? So my function is x squared, and I'm going from 0 to 1. Go ahead. You have 1 minute. You have what is A, what is B, what is F. You try to generate all these things for that specific function, for that specific A, for that specific B. 1 minute starts now. Go ahead, please. Okay, 10 seconds left. Okay, I'm dividing it into n equal subintervals. What is the length of each subinterval? It's the length of the total, the big interval, which is 1 minus 0 divided by n. So that is 1 over n. That's first thing. Delta x for this example is 1 over n. The second thing, xi. Xi, I have a formula for this. A plus I delta x. What is A in this case? 0. 0 plus I times delta x. But delta x itself, I know is 1 over n. So that means I times 1 over n. That is my xi. How about f of xi? Well, my function squares whatever the input is. Here, this will be xi squared, or I squared over n squared. Yeah? That's step 1. I found what is the length of each subinterval. I found what are the formulas for xi's, and I find what is f of xi. Step 2. Now we are trying to find what is Rnf01. Yes? This is sums of f of xi. Let me write this formula and then I plug in. Times delta x. I goes from 1 to n. That's the formula we have here. Yes? But after plugging everything, we see that we have I to the power 2 over n squared plus, sorry, times, this is f of xi, times 1 over n. N goes from, sorry, I goes from 1 to n. Yeah? We are good so far? But I'm not done. Remember that I said that Rn, I have to evaluate it. I have to simplify it and write it in terms of n. And, well, for that, let me do one more step here. You see I have I squared over n cubed. N goes from, I goes from 1 to n. N is fixed. I fixed n at some point. But I know that this guy has no I in it. I can put it outside. And then I goes from 1 to n. Of what? I'm adding I squares. Do you remember what was the sum of I squares? I go from 1 to n? Yes or no? Do you remember it? Say no. No. Say no. No. 10 seconds. Go back to your notes. Find that formula. Tell me what's that. Sum of I squares. I goes from 1 to n. 5 more seconds. Write it down. I want to have that formula when I'm starting writing it. The formula for I squared says I have n times n plus 1 times 2n plus 1 over 6. But I also have n cubed here, so I'll write n cubed there. So let me write this one again. Rn of my function on the interval 0, 1 is, the sum is already gone. I have n plus 1, 2n plus 1 divided by 6n cubed. Are we all happy with that? Yeah or no? Okay. Now, those who were asking, what does that mean in terms of A, B, F, and N? Do you see any A, B, or F in that formula? Not that they are not there. That expression I found, if I have done for general A, B, it would depend on A and B. But in this specific case, when you plug in the values, what will remain at the end would depend only on how many pieces your interval is going to be divided to. For example, someone can come and say, what if I divide the interval 0, 1 to 10 pieces? What would be that estimation that you were talking about? Then it will be 10 times 10 plus 1 times 20 plus 1 over 6 times 6,000. It's a number. I don't know what's that number, but that's a number. Yeah? Isn't that, what number is this? 23, 1, 10? Yeah? Something like that. It's a number. So each time you do those steps, you will get a number. For different n, you will get different number n. That is step 2. Is there any question about step 2 for this specific example? Is there any questions for this guy? Yes, please.
What happens to the 1 over n to the 3?
When I am summing over, you remember there was this property that if I have a summation f of I times c, this c can come out. This 1 over n to the power 3 has no I in it, so it's constant in our index. I can take it outside and put it outside. 1 over n cubed is here. Yes? The summation formula for I squared gives me this. N times n plus 1 times 2n plus 1 divided by 6. And I multiply it by n cubed in the denominator. That's where that n cubed. Yeah. How about you do the last step and give me what is the area under the graph of parabola from 0 to 1. You just need to run one limit, and you know how to do that. Go ahead, please. Go ahead. 1 minute. You have to be able to do it.
Yes,
30 seconds left. What is limit of our n as n goes to infinity? Oh my God. Let me hear the answers. Please tell me the answer. Well, what could go wrong? What did you get for the number there? Limit of our n as n goes to infinity. Please. Yes? 0. What else? We are not supposed to get 0 because we are trying to find that area of that curvy region. Yes?
Infinity over infinity?
Infinity over infinity is not a value. So you have not completed your work. That means that. Yes, please. 1 over 3, what else? What else?
1 over 3.
2 over 6, which is 1 over 3. What else? What else? So I get any other number? 0, yes? 1. Okay, let's see which one is good. So I'm trying to find limit of our n, f, a, b, n goes to infinity. This is limit of this guy, yes? Let's expand this. Let's expand this. 2n cubed plus the n squared part. We have 3n squared plus 1n divided by 6n cubed as n goes to infinity. Yes? I won't leave this room until I find that limit. I promise you. Okay. Here, yes, it is infinity over infinity. If you use the trick that you factor out the dominant term, you do some work here, and you will get 2 over 6, which is 1 over 3. The area of the region under the parabola from 0 to 1, after doing all those painful work, is 1 over 3. Come back Wednesday, we will do some more examples of this.